and talk about what an IP address looks like, let's talk a little bit about what IP is. So IP stands for the Internet Protocol, and it's the main protocol responsible today for routing packets across networks, including the Internet. So if we have packets on network A and we want to get those packets to network B on a different network, we need a way to route those packets. And IP is the primary protocol responsible for doing that. Now, IP, the version we've been using forever, is what we call IP version 4. That's generally what you're going to see on most networks today, and that's primarily what's running the internet today. Now, because we've already allocated all the possible IPv4 addresses, you might have heard a little bit about IPv6. IP version 6 is eventually going to replace IPv4 as the primary protocol to route packets out on the internet and probably on our own private networks as well. But until that happens, IPv4 still very important, and that's what we're going to be focusing in on here today. So now that we know a little bit about the IP protocol, what is an IP address? Well, simply, if we're running the IP protocol, okay, we need a way to address all the different hosts on all of our different networks. So an IP address is basically a way to identify a host on a network that communicates using the IP protocol. Now, specifically what it is, it's a 32-bit number. So for example, this big long bit string that you see right here, that could be an IP address. That's a 32-bit number. So that's all that it is at the lowest level. Now, because there's 32 bits in an IP address, and each bit can have two possible values, that means we can have 2 to the 32nd power possible addresses, or about 4.2 billion. Now, when humans look at a 32-bit long string like that, it's really not very easy to read. We'd all go nuts if we had to manage our networks based on 32-bit binary numbers. So even though the IP address is a 32-bit number, we usually don't communicate it that way. We usually communicate it in a notation we call dotted decimal. So dotted decimal, the way it works, is we take our 32-bit IP address and we split it up into chunks. And these chunks we call octets because each chunk contains 8 bits. So if you take a 32-bit number and you split it into 8-bit octets, you're going to get 4 different 8-bit octets. And then what you do is you convert each octet from binary to decimal. So for instance, octet 1 here, if you take that binary number, it comes out to 192 in decimal. Second octet comes out to 168 in decimal, and then 1.1. Now if you don't know how to convert binary to decimal, you're going to be in trouble here. If you don't know how to do that, check out my video on binary to decimal conversions I did earlier this week out on YouTube. But that's basically the dotted decimal IP address notation. And this gives you a little bit of information on how to convert them. Decimal to binary, very simple. You basically are going to take your octets, write out each octet as an 8-bit number, and put them all together. That'll give you your 32-bit binary address. Binary to decimal is what we just did. Take your 32 bits, split it up into 4 8-bit chunks, and individually convert each octet from binary to decimal. And that's how you get from dotted decimal to binary and from binary to decimal. Now, subnet masks. What you really have to understand about IP addressing is that each IP address is actually made up of 2 different things. Okay? Part of those 32 bits is going to define the network address. Or in other words, what network are we actually going to route the packets to? Another portion of those 32 bits is going to define the host portion of the IP address. So really you have the network portion tells us what network to route the packets to. The host portion tells us, okay, once we've routed to that network, what actual machine or what actual network host do we send the packets to on that individual network? So a subnet mask is a way for the router to understand which part of the 32 bits is for the host and which part of the 32 bits is for the network. And that's what a subnet mask does for us. Now, a subnet mask is actually a 32-bit binary number as well, but we also usually use the dotted decimal notation. So, for example, this subnet mask in binary comes out to 255.255.255.0 in the dotted decimal format, and that mask would tell our router which 32 bits of the IP are for the network and which part of the 32 bits is for the host. So for example, let's say we were given the IP 192.168.1.1 and a mask of 255.255.255.0. When we look at that IP address, let's take a look at the address and the mask in binary. So when we take a look at that, if we see a binary 1 in the subnet mask, that means that the corresponding bit in the IP address is part of the network portion of the address. So here, all these ones across the first 24 bits, that's telling the router the first 24 bits of my IP address are identifying the network that I'm on. If we have a 0 in the mask, that means that those corresponding bits in the IP address are to identify the host on that specific network. So in this case, we've got the first 24 bits identify the network, and the last 8 bits identify the host. So we're going to route to this network, the full 24 bits. Inside that network, I have these hosts. IP address classes. Now originally with the IP protocol, what they did is they took the entire IP address range and they divided it up into 5 different classes called A, B, C, D, and E. Now each class, the class of an IP address, it was just determined by the first octet in the IP. Okay. Also, each class had a default subnet mask. So each class had a default number of bits that specified the network and the host. So class A was 1 through 127 with a default mask 255.0.0.0. So that meant that with a class A address, we didn't have very many class A networks, but we had a whole bunch of hosts. We had a ton of hosts in each class A network. Class B, 128 through 191 with the 255.255.0.0 mask, which meant that the first 2 octets now were for the network and the last 2 octets for the host. Class C, 192 through 223. This time the mask 255.255.255.0. So with this one, that meant the first 3 octets now were for the network and the last one for the host. So with the Class C, we had a whole bunch of Class C addresses, but within each Class C, we didn't have very many hosts inside each network, only about 255. Class D and E were really reserved for special purposes. Class D was for the multicast address range, and E was experimental. We're really not going to get into those today because it's not really important for what we're learning about in this specific lesson, and we really don't have time to cover them, but they're reserved. Then we had private IP address spaces. So we had a standard written called RFC 1918 that defined IP address ranges to be used in private networks, and those are the ranges you see here below. Now, these specific private ranges, they are not routable out on the global internet. They're only to be used on inside private networks. So that's probably why most of you, if you go to work and you check out how things run on your inside network, if you have a private network at work, you're going to see one of these 3 ranges. You'll probably also see these on your home routers because your home inside network is a private network that is not routable out on the internet. So private address ranges. Now we're going to look at something called CIDR notation or classless interdomain routing notation. So traditionally, like we just saw, we had the 5 different IP address classes, and each class had a default mask And the class was determined by the first octet of the IP address, right? So if I gave you any IP, you could have told me by the first octet, okay, which class is it? And because it's in that class, what's the subnet mask? So you only really ever saw three different subnet masks out there. You had 255.0.0.0, 255.255.0.0, or 255.255.255.0. Those were the only three that you saw. Well, what happened was, to preserve IP address space and use those more efficiently, and also to help decrease the burden on the global routing table on all these routers out there, they came up with something called classless interdomain routing, or CIDR. Now, the basic concept of CIDR is that it's used for aggregation, and instead of only having three different subnet masks that we use, they pretty much said no more address classes. Now we can have whatever subnet mask we want for whatever IP address we want. So with CIDR, they came up with a new notation. So you had the network address followed by a slash followed by the number of subnet mask bits. So for example, 192.168.0.0/16. The slash 16 there means that we have 16 bits for our subnet mask. So if we had 16 bits, that would come out to, for example, 255.255.0.0. Another one, here we have a slash 25 mask, meaning we have 25 bits now for our subnet mask. If you took 25 bits, okay, and you converted them over to dotted decimal, you'd get 255.255.255.128. And finally, here we have a slash 30, meaning the first 30 bits of the subnet mask there are all ones, and that would give you 255.255.255.252. And that's about it for the basics of IP addressing. Now there's a whole lot more when you get into things like subnetting, IP subnetting. We're going to be talking about that in some upcoming videos. This video is just for the very basics of IP addressing, and hopefully you guys